In this question, we are given that the internal temperature of the potato is given by this differential equation, and that the initial temperature at time 0 is 91 degrees Celsius. And so the question is to write an equation for the line tangent to the graph of this h at t equals 0, and use this equation to approximate the internal temperature at time t equals 3. So first note that h of 0 is equal to 91, so we have the one point through which this tangent line will go through. So we can say that x0, y0 is equal to 0, 91. And so we need to find the slope. And to find the slope, we can plug in h equals 0 in here, and we will find the slope of this line. So dh over dt at a time t equals 0 is equal to negative 1/4, 91. This is the value of h at time 0 minus 27, which is 91 minus 27 is 64. 64 divided by 4 is 16, so it's negative 16. So then the equation of this line that has this slope and goes through this point is y minus y0 equals m x minus x0. And so plugging in those values, we get that y minus 91 equals negative 16x, because x0 is 0, negative 16x. And so the equation is y equals 91 minus 16x. This is the equation of the tangent line. And so to approximate it, we need to then plug in, instead of x, 3. So we get that y at time t equals 3, and I'm using x and t interchangeably here, and y and h. So this is really, instead of y should be h, and instead of x should be t. So y at time equals 3 is 91 minus 16 times 3, which is 48. 91 minus 48 will be equal to 43 degrees Celsius. So this is our answer. These are our two answers. In this question, we are being asked whether our answer in part A is over or underestimate, and we need to use the second derivative of h with respect to t to determine that. And so let's calculate the second derivative of h with respect to t. And because h with respect to t, the first derivative is a function of h, we need to rewrite this as d over dt of actually dh over dt. And this is a function of h, so we do chain rule here, d over dh of dh over dt times dh over dt. And dh over dt is this second dh with respect to dt. So what is our derivative with respect to h of this expression? Is just negative 1/4 times, and the derivative itself is this number here, which is negative 1/4 times h minus 27, which is equal to positive 116 times h minus 27. Note that we are given that the internal temperature of the potato is greater than 27 for all times t greater than 0, which means that this expression is always greater than 0, times 1 over 16 means that this entire expression, the second derivative, d to h over dt squared, is greater than 0. Which implies that the graph of h is concave up for t greater than 0. And we know from here that the h with respect to t is decreasing. So really, we can just draw this a little bit like this to imagine. This is point 91. This is somewhere here, point 27. And then we know that the graph never goes below 27. So this function is decreasing, but somehow concave like that, right? And so the tangent line here, as we know, was like this, because it had a negative slope here. So approximately, if this is point time equals 3, our estimate in part A was underestimate of the true value. So 43 was lower than the actual temperature at time t equals 3. In this question, we are given new function g, which satisfies this differential equation, and the same initial condition. We need to solve for g of t, and then based on the model, we need to find the temperature of the potato at time t equals 3. And so let's solve this differential equation by separation of variables, which means bringing all variable g to the left-hand side and all variable t to the right-hand side. So we get dg divided by g minus 27 to the power 2/3 equal negative dt. Let's integrate both sides. We get here integral from g minus 27 negative 2/3 dg equals negative t plus a constant. Don't forget that we need to include constant. And now I wrote this way because we see that this is a power function with a power negative 2/3. So integrating this, we will get this is equal to g minus 27 to the power 1/3, and then this one will be 3/1 equal to negative t plus c. Let's plug in the initial condition, which is g of 0 equals 91. So 391 minus 27 to the power 1/3 equals 0 plus c. And 91 minus 27 is 64. Cubic root of 64 is 4. 4 times 3 is 12. So 12 equals c. So c is equal to 12. Now we can continue writing this. We'll get 3 g minus 27 to the power 1/3 equal to 12 minus t. And so let's solve for g. G minus 27 to the power 1/3 equal to 12 minus t over 3. Cube both sides, will get g minus 27 equal to 12 minus t over 3 cubed, and then plus 27 gives us g equals 27 plus 12 minus t over 3 cubed. And so this is our explicit expression for g of t. And so based on this model, let's plug in t equals to 3. We get g of 3 is equal to 27 plus 12 minus 3 over 3 to the 3rd power, which is equal to 12 minus 3, 9, divided by 3 is 3, 3 cubed 27, and then 27 plus 27 is 54 degrees Celsius. And so this is our final answer. These two are our final answer. This is for the functional form, and this is for the number actual temperature. Thank you, and I will see you in the next question.